Hello, welcome to geography class with Mr. Ijola Clement. Okay, before we start today's class, or before I introduce the topic I'll be teaching you, let us look at this starter activity. So you have to watch a video, and from there you are going to tell me the topic we're looking at today. The video is just about 2 minutes, and thereafter you will tell me the topic that you think we'll be looking at today. Okay, let's start.
Hello friends, today we will learn about plate tectonics. Hey buddy, what's up? Oh wow, it looks awesome! All the 7 continents of the Earth were once joined together like pieces of a jigsaw puzzle? Have a closer look on this. If you move the continents of South America and Africa close enough, they would fit together like 2 perfect pieces of the puzzle. A German geophysicist, Alfred Wegener, presented the concept that the Earth was nothing but a huge jigsaw puzzle. This area gradually got divided into 7 parts that we now know as the 7 continents. Our Earth is round like a ball, full of land and ocean. The Earth is made of 4 layers: the crust, the mantle, inner core, and the outer core. Come on, have a closer look on this, guys. Whoa! The crust is not a single solid continuous land. It is broken in so many pieces. These parts of the Earth are called the tectonic plates. These plates keep floating on the hot molten inner layers of the Earth. The plates are about 100 kilometers thick and consist of 2 major types of materials: oceanic crust and continental crust. You must be wondering, what moves the tectonic plate? The plates move using 3 types of movements. They are convergent, divergent, and transform movement. Let's learn about them one by one. Convergent. In this movement, the plates move towards each other and give rise to geographical structures like volcanoes and mountains. The Himalayas was built by this movement. Divergent. In this movement, the plates move apart. The magma from the interior of the Earth flows toward the surface and moves the tectonic plates away from each other. The Mid-Atlantic Ridge is an example of this type of plate boundary. Transform. In this movement, 2 plates move sideways with respect to each other. California's San Andreas Fault is a transform boundary. When the 2 plates rub against each other, a huge amount of energy is built up, and this energy is released as earthquakes. The major effects of earthquakes are ground shaking, landslides, ground rupture, tsunamis, liquefaction, and more. The place where the earthquakes originates is known as the hypocenter, and the place where it occurs on the Earth's surface is known as the epicenter. Now you know a lot about plate tectonics. Stay safe and always help others. Bye-bye.
Okay, thank you for watching the video. Okay, can you now tell me the topic we are looking at for what you've just watched? Can you tell me the topic? Oh wow, very good, very good. So we are looking at what's called tectonic plates, tectonic plates, tectonic plates. That's what we'll be looking at today. And let us look at our learning objectives, because our learning objectives will reflect some of the things we'll be looking into under this topic. Okay, these are the learning objectives. Number 1 says to understand what tectonic plate is. To understand what tectonic plate is. And the second learning objectives is to describe the types of crust and plates. And the third one says to describe the plate boundaries. So these are the 3 learning objectives we'll be looking at under this topic called plate tectonics. Okay. And before we start, let us look at our keywords. These are the keywords we'll be coming across: plates, crust, oceanic, continental, plate boundary, convergence, and divergence. So these are the keywords we'll be looking at as we proceed our lesson. Okay, so let us start from the first learning objective. The first learning objective, which says to understand what tectonic plate is. Okay, before I tell you what it is, can you tell me what it is? Can you predict? Can you just try and give me an idea of what you think tectonic plate is? Oh, wow, 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 wow. What a good idea. That's good. That's good. That's good. Okay, now let me give you my own definition of a tectonic plate. Okay, okay. Oh, before I show you this, let me tell you what uh, tectonic plate is. Okay, so you can see from here the crust of the earth is broken down into giant pieces. These giant pieces are called tectonic plates, and sometimes or often they are called plates. So anytime you want to tell us the meaning of tectonic plates, just tell us that they are the broken giant pieces of the earth crust. You observe that from the video you watched, you were told that the crust of the earth are not just one, they are not just single, they are broken pieces. And each of these piece is referred to as plates. Okay, so the crusts are in broken pieces. Each of them is what is referred to as plates or tectonic plates. Okay, I hope you understand what tectonic plates are. They are the broken pieces of the earth crust. And look at this diagram here. You can see this diagram. Inside of it is the mantle, and outside of it, they are the broken pieces, the broken pieces of crust, and each of them is called plates. Plates. Okay. Now let us look at this plate into detail. Okay. Now, if you look at what I'm showing you here, you will discover that there are seven major or primary plates. Seven major or primary plates. And they are the African plates, Eurasian plates, North American plates, the South American plates, Pacific, Indo-Australia, and Antarctica. Okay? If you count all these plates, you discover that there are seven. One, two, three, 4, 5, 6, and 7. So these are the seven major plates. And if you look at these plates, they are named after the continents. African continent, the Europe continent, the North America, the South America, the Pacific, the Indo-Australia, and the Antarctica. Okay, so these are the seven major or primary plates. Okay, so now aside the major and all the primary plates, we also have the minor ones, the smaller ones. Okay, and they are also seven in number, and they are Nazca, Cocos, Caribbean, Scotia, Arabian, Philippine, and Juan de Fuca. So these are the seven smaller secondary plates, and you can see them on this map here. You can see the smaller ones and you can see the bigger one. or the major ones and the minor ones. Okay. Now, I want you to take note of this. Don't forget I told you that beneath the crust is the mantle, and this mantle is what is responsible for the plate movements. There is a convectional current within the mantle. This convectional current going on within the mantle is what is responsible for the movement of the plates. Okay, and you can see it from this map, the various types of plates. You can see the North American plates, you can see the South American, you can see the African plates, you can see the Eurasian plates, you can see the Pacific plates, you can see the Indo-Australia, you can see the Antarctica. Then for the minor ones, you can see the Cocos, Caribbean, Nazca, Juan de Fuca, the Arabian, the Indian, and so on and so forth. Okay, so I hope you understand the difference between the major plays and the minor plays, and I want to believe the fact that you can give me the examples of the major plays and also the examples of the minor plays. Okay, that's very good. And this leads us to the second learning objective, which is to understand the types of crust. The types of crust. Okay. Let me before I show you the types of crust we have. Can you predict? Can you tell me at least from the video you must have heard some things about the cost. Can you tell me what are the types of cost? Can you mention them? Okay, okay, that's very good. Okay, now let me show you the types of crust we have. Okay, we have types of crust. Two types of crust. We have oceanic crust, we have the continental crust. Okay, the oceanic crust and what? And the continental crust. The oceanic crust is found under water or under the oceans. That's why it is called oceanic, because it is found under the ocean. We have the continental crust. That continental crust is found under the land. Continental is found under the land, while the oceanic is found under the ocean. And we can quickly look at the major differences between the two. The first one is that oceanic crust is younger, while continental crust is older. The second one says that the oceanic crust is normally thinner, while continental crust is normally thicker. Then third one says oceanic crust is denser, that is heavier, while continental crust is less dense. Next difference says oceanic crust can be destroyed, but in the case of continental crust, it cannot be destroyed. Then the last difference is that oceanic crust can be made, but continental can't be made. So these are the major differences between oceanic crust and what? And continental crust. Okay. I hope if I ask you at the end of this lesson the major difference between the types of crust, I'm sure you'll be able to tell me, oh, that's nice. Don't forget, we've looked at the plates. Okay, we've looked at the meaning of tectonic plates or the meaning of plates, and from there we looked at the crust. Okay, the types of crust and now the major differences between the two. Now we want to look at the third learning objective, the third one, which has to do with the plate boundaries, which has to do with the plate boundaries. Okay, to describe the plate boundaries. That's our third learning objective. Okay. Now, what is plate boundary? Plate boundary. What is the meaning? When we are talking about plate boundary, we are talking about the space in between two plates. Don't forget, plates are in broken pieces, and at a point they meet at a point. The meeting point, the space in between the two plates, is what is known as plate boundary. And it is good we know direction of movement of plates. Okay, sometimes plates moves apart, sometimes plates move towards each other, and sometimes plates move alongside each other, alongside alongside each other. Okay, those are the three direction of movement of plates, and you are going to see each of these movements as we move further. So we are going to look at the types of boundary, or the types of plate boundaries we have. Okay, the first one we'll be looking at is what we call destructive. Oh, constructive. That's the first one we'll be looking at. Constructive plate boundary or divergent plate boundary. Constructive or divergent plate boundary. That is the first one we are going to look at. Okay. Now, at the constructive or divergent plate boundary, two oceanic plates are involved. Two oceanic plates are involved. That is, the two plates are moving away from each other. The two plates are moving apart from each other. Okay, and as they move apart under the ocean, it causes what is called seafloor spreading. This simply means ocean floor getting wider. That is what is meant by seafloor spreading. Okay, and not only this alone, the movement of the two plates apart causes magma to escape. Okay, it causes magma to escape from the mantle. Now, as this magma escape and it touches the water, it cools and solidify. It cools and solidify. And as this occur consistently, then oceanic ridge is formed because consistent accumulation and solidification of floating magma will pile up and form what is called oceanic ridge, as you can see here. Okay, and best example of this is the mid-Atlantic ridge. Okay, and at this point, the eruption is not violent. It is a gentle one. It is less violent, but more consistent, more constant. Okay, and these volcanoes can cause the problems of Laos in Iceland. And I need to let you know what Iceland simply means, how Iceland is formed. You know, I told you the other time that this molten magma cools and solidifies the moment it touches water. And when this continues over a period of time, the ridge will break the surface of the water. And when it breaks the surface of the water, it forms a particular landform. And that is how Iceland is formed. I'm sure that you must have heard about Iceland before. Look at the diagram here. Okay, you see that if you look at this diagram, you see that we have two arrows. You have two arrows moving away from each other. The North American plate is moving towards the left, the Eurasian plate is moving towards the right. Okay, then in between them you have mid-Atlantic ridge. Then in the process of time you have what is called this Iceland. This Iceland formed from mid-Atlantic ridge. it starts from mid-Atlantic ridge, and that's how Iceland is formed. Okay, so those are the things you need to take note of when you are talking about the constructive or divergent plate boundary. Okay, I hope you understand that. Okay, don't forget divergent plate boundary, plate moves apart. As plate moves apart, it causes seafloor spreading. Okay, and seafloor spreading simply means the base of the ocean or the floor of the ocean is getting more wider. And not only this alone, you have eruption of magma gently, not a violent one, a gentle eruption. And as this eruption takes place, the magma touches the water and it cools, becomes solidified. Consistent accumulation of this results into what is called oceanic ridge. Then in the process of time, this oceanic ridge breaks the surface of the water and form what is called this Iceland that we are seeing here. Thank you for this uh, key points that you have taken note of, because at the end of the lesson, I'm going to give you a task related to this. Okay, so now we need to look at the second type of plate boundary. We've looked at the first type, which we call constructive or divergence. Now, the second one is called destructive, destructive plate boundary or convergent plate boundary. Now, at this point, it involves oceanic and continental. Don't forget, the very first plate boundary we talked about, the two plates involved, I mean, or the crust, either you call say crust or plate, the two involved are oceanic. Okay, but in this case, it has to do with oceanic and what? And continental. Now, collision takes place because both of them are moving towards each other. Like you can see on the diagram below, you can see the two arrows coming towards each other. You can see oceanic plates and the continental plates coming towards each other. Now, something is going to happen here. By the time collision has taken place, because oceanic is more denser than continental plate, oceanic sinks under the continental plate. And don't forget, immediately you leave the crust, you are going to the mantle. So this oceanic sinks into the mantle, okay? And at the point where it sinks under the continental is what is known as subduction zone. Subduction zone. And at this place, magma rises to the surface through the cracks, okay, and causes eruption, okay. And at this point, eruption is always violent. Eruption is always violent. And at this point, you should expect big earthquakes. When oceanic and continental collide, it is always disastrous, very, very disastrous. It causes volcanic eruption and it also causes earthquakes. So take note of this. Number one, the plates move towards each other. It involves continental and oceanic. The continental sinks under the continental into the subduction zone, thereby giving room for magma to rise and escape to the surface of the earth through cracks. Okay, and I told you that eruption here is what? Always violence. And earthquake is what? Always disastrous. Those are the things you have to take note of under destructive plate boundary. And now we look at the third type of a plate boundary, which I call transformative or conservative plate boundary. Transformative or conservative plate boundary. Here, plates moves alongside each other. You can see the arrow showing how plates are moving alongside each other, and it involves two continental plates. Don't forget the first one involved two oceanic, the second one involved oceanic and continental, and the third one that we are looking at now is saying two continental plates. You can see two continental plates, okay, move alongside each other. Now, because the plates are not being forced up or down, there are no major landforms. No major landforms. But here, volcanoes found at this boundary, however, there can be a build-up of pressure between the two plates. So, what this is telling us is that when there is build-up of pressure between these two plates, gigantic, disastrous, massive earthquake can happen here, because the plates are moving alongside each other. So there's a tendency for friction to occur. When friction occurs and the plates can no longer move freely as they're supposed to move alongside each other freely, then there's going to be an hanging up between the two. At that point of hanging off, because conventional current is still going on within the mantle, okay, they will be trying to force themselves to move, to leave each other. And as they are trying to force themselves, pressure is developing. And at the time, earthquake is released at this point. Okay, so that is transformative plate boundary. Plates move alongside each other. It involves two continental earthquakes, massive earthquakes occur here. But take note, no major landform here and no volcanic eruption here. But there is what? Massive earthquake. Okay? Then don't forget the second one we looked at, which is destructive or what? Can you tell me? Destructive or what? Convergent plate boundary. Okay, we said it involves oceanic and continental. Okay, so take note of that. Take note of that. I've said there violent eruption can take place and also earthquakes can take place there. Okay, and before I end the class, I want to hear from you. Can you tell me any three things you've learned from the class? Any three things, okay? Can you tell me? Oh, very good, very good. You have learned that uh, broken pieces of the earth crust are known as tectonic plates. Very good, very good. Okay, you have learned that the boundary between two plates are called plate boundary. Very good, very good. You've learned that the three types of plate boundary are constructive, destructive, and transformative. Very good of you. Very good of you. And I'm going to give you an assignment, and the assignment is very simple. You have to draw out the three three plate boundaries. Three plate three plate boundaries that I've taught you today. Draw it in your notes, and you have to submit it by 5th of December 2023. That is when you must submit the assignment. Okay, and before I release you, do you have any question? Okay. Oh, very good, very good. So that simply shows that you understand what I've taught you very well. Okay, don't worry. In my assignment, by the time you submit your assignment, I will know your in-depth of understanding of the topic. Thank you so much for coming to class today, and by the grace of God, we meet next week. So enjoy yourself till we meet. I say bye, 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 bye. Bye bye. Okay, bye. Bye bye. Bye bye. Bye bye. Thanks. Bye bye.